So this is, maybe I should tell you what this is all called. This is called the differentiation from first principles, okay? We'll come back to the phrasing later. All right, so let's go back to this graph. We've got y equals x squared. So we know it's a parabola. We can see from the parabola that the gradient of it is changing. Okay, so as the value of x changes, the gradient of it changes. So if I were to look at the this point here, it would have this corresponding value of x. How do we find the gradient? Well, we would draw a tangent to the curve at that point. Okay, remember, a tangent shouldn't touch it. So a tangent to the curve at that point, and we would do as we normally do and would find rise over run. What can we see about this gradient as it is? Negative. It's negative. Okay, is it quite high negative? Is it small negative? High negative. Okay. If I were to look at this value of x, again, I can draw a tangent. What do we know about that gradient? Negative still, but it's low. If I was to look at this point here, low positive. Okay? So the gradient changes as this value of x changes. Calculus pretty much just looks at the x values. Okay, so we're always focusing on the different values of x. It's always to do with this variable here on the bottom. We don't really look too much about the y values. All right, so now let's look at this portion here. I'm considering this point P. What I've done here is I've drawn a tangent to P, and then this box here, I've zoomed in on it, and that's what we've got here. All right? So this is my curve. This is my y equals x squared curve, and this line here is my tangent. All right? So this point P has this value of x. This point Q, remembering that we've zoomed in quite a lot, it's really, 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 really close to it. Okay, it's what we're going to call h units apart from it. So if we're saying that it's h units away, how could I describe this x coordinate? X plus h. Love it. Love it. Okay. Now, if this value is x, this is p, how would I describe this y coordinate? Think about what we've called it. Y, or in this case, I'm actually going to stick with fx. You all happy with that? Because my function, I'm going to stick the value of x into it, so it would give me fx. How could I describe this y value? How could I describe that one? H. Or secretly h, yep. Because remember, it's the h that we've added on. So this would be f of x plus h. Yeah, you all with me? Let me pause. All right, okay, so let's actually fill in these gaps here. So we've looked at the diagram. So if we wish to find the gradient of the curve at the point P, then we're going to let Q be x plus h. So we talked about that already. And we said that the y coordinate would be f of x plus h. And we've said that that's a point where h is really small. Okay, so it's so close to P, but it's just a little tiny bit away from it. Now the reason we do that is because if I were to draw this line here and measure this distance divided by this distance, that's how we find our gradient, isn't it? It's rise over run. Okay? But when we're drawing our tangent, because there's a lot of human error involved, you're going to get very different answers to that. So what we're trying to do here is we've drawn our tangent, and we're just taking a point that's really, really close to it, and we're going to do that rise divided by that run. Yeah? Does that make sense? So we're doing the rise over the run to find the gradient of it. So down here, we've got the gradient can be found plus. Oh, that's a fancy word. So m is our gradient of PQ. It's the change in y. over the change in x. This is a fancy thing. Delta, have you seen that before in science? Okay, oh, check you me. What else? Alright, so it's the change in y over the change in x. Now, basically, I want you to now consider that as dy dx. If you want to consider it as difference in y over difference in x, you can.
I think we did this last year.
You did do dy dx last year, yeah.
Yeah.
I don't remember the graph part.
I remember doing it.
Yeah, you wouldn't have necessarily looked at it in this format, okay? Because so what we're doing here is a little bit more specific. So okay, so how am I going to find the difference in y? Think about it up here. If I go back up to the thing, how am I going to find the difference in the y values? So these are the two y values. What am I going to do? What am I going to write? Nice. F of x plus h minus fx. Perfect. And then what am I going to do to find the difference in my x values? Tres bien. No, you don't have to. Just because they're adding together, you've got nothing multiplying by it, and then you're just subtracting after it, so you don't need it. But what does happen here on the denominator? Yeah, because we've got x minus x, so they're actually going to go. So what this simplifies to be is f of x plus h minus f of x over h. Woo!